Welcome to the lecture series on 8051 microcontroller. Today we'll be discussing about the Boolean instruction set. So you could see here these are the Boolean instruction set. The clear set, it is basically set B, not set, just set B. Then complement, and this is and, or, move, and these are some jump instructions which we will discuss in next video. Okay. One thing to note here is that some of the instructions we have already studied in case of logical instruction set. So those were actually byte instructions, and this is bit instruction. The difference between the two is that these instructions, which are bit instruction, operate on bits. Okay, so that's the difference. While the instructions which we used in case of logical operation, that were byte operations. So that's the basic difference. Okay, so let us take one by one and we will try to see how they operate. Okay, so let's start with the clear instruction CLR C. Okay, so it's quite simple. It basically results in making the value of C equals to 0. That is, 0 is saved in C and C becomes 0. C is basically the carry flag of the PSW register. Okay, uh, this instruction can also operate on any bit. That means we can write CLR. I can write here like say P 1.2, or I can write CLR, say I may write here say 0 1 H, or I may write here CLR A ACC point 6. Okay, so all these instructions are basically clear instructions. So what they are doing, this is port 1 bit 2, so it will make the bit 2 of port 1 equal to 0. Similarly, this is a bit memory address. If you remember, this is a bit memory address, so this address will become 0. This is a bit address and will become 0. Then sixth bit of the accumulator, sixth bit of the accumulator will become equal to 0. So SAC dot 6 equals to 0. Okay, so let's move and see another instruction. So this instruction is your then we take up the CPL instruction. CPL instruction is the complement instruction, and as the name suggests, it complements the value of C. It, again, it can be used with any other bit. Remember, there is no comma sign between the instruction and the bit. Okay, so like I use CPL 01H. So what, say for example, in 01H 1 was stored, so after this instruction the value of this address will become equal to 0. So complementary action will take place. Okay, now let us take another instruction, which is set B. Set B instruction. So set B C, or set B say any other bit. Okay, so as the name suggests, it makes the value of the carry flag equal to 1. Similarly, any other bit, either it could be an address or it could be say P1.2 or accumulator 0.5. So if I am using the set B instruction with them, then it is going to make these bits equal to 1. So this is your set instruction. Let us look into another instruction, which is CLR. So CLR, again C or any bit. So again, it's simple, make C equal to 0. and any of the bit equals to 0. Okay, then let us look into another instruction, which is then we will take up the move C comma B or your bit. Okay, so what this is going to, this is we know that this is a data transfer instruction move, but earlier we used it for transferring 8-bit data between two addresses or from accumulator to a register or vice versa. Here we are basically moving one bit from one position to another. So let us take one example. If I'm writing move C comma say 01H. Okay, what it means, so say for example 01H was having a value of 0, and after this instruction, now C will, the carry flag will now be equal to 0. So basically this value 0 has been transferred to the bit C, the carry bit. Okay, so this is your, and similarly we could have bit comma C also. So the operation could be in reverse direction. Okay, then let us take another instruction. It is ANL C comma bit. Okay, so ANL, it is AND. So this is not byte ending, it is bit ending. So if C equals to 1 and say I'm using say 01H here in place of bit. Okay, and this 01H was having a value 0. So and after this execution of this instruction, C will be having a value 0, because ending these two will result in 0. The value is stored in C. Okay, then the reverse can also happen. Similarly, there is another instruction ANL C comma backslash bit. Okay, so what it means, it means basically ending C with the not of the bit. Okay, with the not of the bit. If I try to apply it for this example, then this is the bit and it was 0. So first this bit will become 1. Okay, so this will become 1 because not of this bit will make 0 equals to 1. Then 1 is then ANDed with C, which was having a value C, and the final result which will be stored in C will be equal to 1. Okay, so again it's not very difficult, very simple instruction. Then we have your ORL instruction, C comma bit. Okay, again we have C comma backslash bit also. So on the same pattern, this is basically ORing operation. So C was, if C was 1 and the bit I am taking again 01H, then 01 was say 0. So ending C equals to 1, and this will result in C equals to 1. Okay, and uh, then yes, then this bit operation again, bit is first complemented. Okay, so this 0 becomes 1, and ORing it with C again result in C equal to 1. So these are some of the some of the Boolean instructions. We will see the the looping instructions when we discuss the program branching instruction of 8051 in the next lecture. For the time being, thank you.